Alright, today is just a review of solving quadratic equation. This starts off Unit 3, polynomial functions. Now, whenever we're solving quadratic equations, you may use any method in this class, and I'm never going to dictate to you which method you have to use. You could use your graphing calculator on some of them. Sometimes that doesn't cut it. Or on a problem like example 1 here, you could solve it by factoring. So don't forget about that option, that this could factor to x minus 7 times x plus 2, because 2 times negative 7 is negative 14, and adds to negative 5, and that would equal 0. And then what you could do is set your factors equal to 0 by the zero product property. This is all a review of Math 1 and Math 2 right now. So here we'll add the 7, and over here we'll subtract the 2. So your two solutions would be 7 or negative 2. Now obviously I recommend that you actually check these answers in the original equation and make sure you get 0 when you type it in. On to number 2 right now, some people are really all about a quadratic formula. If you're using quadratic formula on this problem, you have to make sure that your c is equal to 0. But honestly, anytime that you have an ax squared plus bx kind of problem, you should probably use factoring, because the greatest common factor here is x, which would leave you 3x plus 5. Now set both your factors equal to 0. I'll set the x equal to 0, and I'll set the 3x plus 5 equal to 0. Now x equals 0 is one of my answers, and over here when I subtract the 5 and divide by 3, I get x equals negative 5 thirds. And there's our two answers. Alright, looking at example 3 right here, it is in standard form. If you're using quadratic formula, you'll need to use 0 for your value of b, but this one is not factorable. What I would do here is I would actually go ahead and divide everything by 2 since it's a common factor. So I'm going to pick this up on the top right here. So I turn this into 1x squared plus 44 equals 0. Now I'd subtract the 44 from both sides, because this could be solved by using square root method. So I'll take the plus or minus root on both sides. It is important that you take the positive or negative root on both sides, because x could equal either one. Now I'll simplify this. If you took Math 2 previously, you might not have been taught this, that this is actually an imaginary solution because you're rooting a negative value. So I'll make this I times the root of 44. That's the imaginary solution. The imaginary number is I, which is the root of negative 1. Now I just need to simplify root of 44. I do know that 4 goes into that 11 times. And I can square root the 4 to be 2. So I'm going to get an answer of plus or minus 2i root 11 as my final answers. That is two answers. 2i root 11 and negative 2i root 11 are my two answers. Alright, for number 4, this one is not factorable. If I get it into standard form, x squared plus 8x minus 4 equals 0. I can't factor this one, nor can I do the square root method due to it having this 8x. I'm going to have to use either completing the square or quadratic formula. For this one, I'm going to use completing the square. You're allowed to use quadratic formula if you prefer to. If I'm completing the square, I'm going to pick this up on the top right here. X squared plus 8x. I'm going to leave that constant value, the 4, on the right-hand side. Now, to complete the square, you always use the formula b over 2 squared, which in this case the b is 8. So 8 over 2 is 4, 4 squared is 16. That's the value I'm going to add to both sides of the equation to complete the square. And what I mean by that is, now the left-hand side of the equation is a perfect square trinomial, and it factors to x plus 4 squared. It'll always factor to whatever b over 2 was. Equals 20. Now I'm going to plus or minus the root on both sides. I'm going to simplify that root because I know I can actually take the square root of 4, which is 4 times 5. So this is going to be 2 root 5. I should say plus or minus 2 root 5. My last step is to subtract the 4 from both sides. And how my answers will be negative 4 plus or minus 2 root 5. So one of my answers is negative 4 plus 2 root 5. My other answer is negative 4 minus 2 root 5. And those are my two real irrational answers. Alright, this is another one I'd probably complete the square with. First thing I'm going to do is get into standard form though. So x squared minus 6x plus 81 equals 0. I'll notice really quick I can't factor this. So what I'm going to do is I'm going to go ahead and kick the 81 to the other side. Now, things I'm looking for whenever I'm considering whether I'm going to complete the square or quadratic formula. First of all, I'm only ever going to complete the square if my leading coefficient is 1, as it is here. Also, I'll look for my b value to be an even number, positive or negative, even integer. Now I'm going to complete the square using, again, b over 2 squared. So that's going to be negative 3, which when you square negative 3, you get positive 9. So I'm going to add 9 to both sides to complete my square. Now the left-hand side factors to x minus 3 squared, again, whatever b over 2 was, and that's because negative 3 times negative 3 is 9, negative 3 plus negative 3 is negative 6, that's the reason why it factors to that, equals negative 72 on the right-hand side. Now plus or minus the root of negative 72. I know this is going to be imaginary, so I'm going to go ahead and pull out the I, and with 72, I know 36 goes into it twice, 36 being a perfect square. So 36 times 2, the square root of 36 being 6, so plus or minus 6i root 2. Now all I got to do is just add the 3 to both sides. So I'll have x equal to 3 plus or minus 6i root 2. And there's my answers. 2 imaginary roots. All right, finally, a time where I say, hey, let's use the quadratic formula. Because my a value is 5, I don't want to have to divide everything by that and deal with fractions using completing the square, so I'm going to use quadratic formula here. In case you're needing a reminder of what the quadratic formula is, it is negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm going to go ahead and set that up here, that my b value is 14 plus or minus the square root of b squared minus 4 times a times c. Careful here that the c is negative 6. That does make a big impact on the problem. Over 2 times a, 5. Now I'm going to start simplifying things down as much as I possibly can. Sometimes it's not very far. We'll see how far we can get here. So whenever I simplify the 14 squared minus 4 times 5 times negative 6, all I'm doing is I'm actually just typing all that in my calculator at one time. And 2 times 5 is 10 on the denominator. Now I have to simplify the root of 316. Now that's a little tougher, but what you end up getting is that the 4 goes into it 79 times. So I get 2 root 79. Negative 14 plus or minus 2 times the square root of 79 over 10. My last step is to look for any common factors that can divide out of this, and that is a 2. So when I divide the 2 out, I'm going to have negative 7 plus or minus 1 root 79 over 5, and I am done. I've got 2 real irrational answers. For my last problem, I'm going to write a quadratic equation where I am given a root. Since the root is 2 minus 3i, that by default means that 2 plus 3i is also a root. It's called a conjugate pair. It always happens for imaginary answers and irrational answers. Now, that's what tells me what x is equal to. It's equal to 2 minus 3i, and x is also equal to 2 plus 3i. From that, I can actually figure out what my factors are. Here, I'd get this equal to 0 by subtracting the 2 over and adding the 3i over, so that way it equals 0. X minus 2 plus 3i is one of my factors. Over on the right-hand one, I'm going to subtract the 2 over. I'm also going to subtract the 3i over to get it equals 0. This is my other factor. Now all I got to do is just take my two factors and multiply them together. Now to do that, I'll distribute the x to all three things. That would give me x squared minus 2x minus 3ix. Now I'm going to go back and distribute the negative 2 to all three terms. So I'm going to get minus 2x plus 4 plus 6i. Now I'm going to go back and distribute the 3i to all three terms. So plus 3ix minus 6i minus 9i. I squared equals 0. Now this looks like an absolute hideous mess, but it really is pleasant once you start seeing what cancels out. For instance, the negative 3ix cancels with the positive 3ix. The positive 6i cancels with the negative 6i. What I'm left with is x squared, negative 2x minus 2x makes minus 4x, plus 4, that I didn't have anything to combine with, minus 9i squared. Now really quick, I squared is negative 1 due to what the imaginary number is defined to be. If you'll remember, I equaled the root of negative 1. So when I square it, I get negative 1. So x squared minus 4x plus 4 is going to actually have 9 added to it due to negative 9 times negative 1 is positive 9. And so my final answer is x squared minus 4x plus 13 equals 0, and there I go. Now you can check your answer by storing one of these two values as x and typing in this equation, making sure your calculator gives you 0 when you hit enter. That wraps up today. Let me know what questions you got.